Dear students, previous class we are discussing regarding the wave nature and particle nature of the substance. Now in this session we will discuss very important concept, it is Bohr's atomic model, okay, and which is very important for the exam point. They may ask for 3 mark question, okay, 3 mark question, 90% sure. Okay, so what is that? Bohr's atomic model of hydrogen atom. Bohr's atomic model of hydrogen atom. Now first we'll move for hydrogen. Hydrogen ಬಗ್ಗೆ ಸ್ವಲ್ಪ discuss ಮಾಡುವ. What is that? Hydrogen having the 1 proton 1 mass number, or atomic number 1, mass number is 1. Here how many electrons are there? 1 electron is there. And last class ಅಲ್ಲಿ ನಾವು energy levels ಬಗ್ಗೆ ಸ್ವಲ್ಪ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ. Okay, what is that? Here if any atom that consists 3 fundamental factor, proton, neutron and electron. Here proton and neutrons are located at the center where the electron is present, electron present at the circular path of the what respective nucleus. Okay, here these are all the path of particular electron movement. Okay, so circular rings are path of the particular electron movement. Okay, now we'll discuss the postulates of Bohr's atomic model. E atomic model alli there are very important postulates are there. Then that will discuss one by one. First we'll directly go for the first postulates. What is that? Electron in an hydrogen atom. Okay, this is regarding only the hydrogen atom. Hydrogen atom ಬಗ್ಗೆ ಮಾತ್ರ Bohr's postulates ಕೊಟ್ಟಿರುವಂತದ್ದು. Here first postulates, electron in the hydrogen atom revolve around the nucleus in a circular path, and with a fixed energy and the radiation. Here electrons are present. These electrons revolve around the nucleus. Here red color circle indicates the nucleus. Now it is a nucleus, and electrons are revolve around the nucleus, and the conditions are applied. What are the conditions are applied? With a fixed radius. That means what? Center to this distance should be r adre, here entire circular region that should be r only. Okay, this is what radius, fixed radius, and the fixed energy of what electron should be fixed. There is no change with the time. Okay, and Rutherford ಹೇಳಿದಾನೆ ಏನು, electron energy revolve ಆಗಿ then it collapse with the nucleus. But here Bohr says what? Electron of an hydrogen we should be revolve around the nucleus with a fixed radius and fixed energy. Okay, and this particular path is called, what is that? Electron nucleus na sutta enu particular distance alli revolve aagta ide, that path called as an orbit. Okay, so this is the first postulates of what? Bohr's atomic model. This is very important for the exam point. Okay, so write as it is. Okay, electron of an hydrogen atom revolve around the nucleus with a fixed radius and energy. These two terms are very important. Okay, in these postulates, fixed energy and radius. Energy should be fixed. Then move for the second. Energy of an electron does not change with that time. Here electron is present which is revolve around the nucleus, and the first postulate says it's having fixed energy. This energy should be same at all time. Okay, ಎಲ್ಲ time ಅಲ್ಲಿ ಕೂಡ ಬೇರೆ time ಅಲ್ಲಿ changes ಆಗುವುದಿಲ್ಲ, it should be same. Okay, this is the second postulate. Energy of an electron does not change with the time. But last class alli ಒಂದು concept ಹೇಳಿದೀನಿ, that is the excitation. What is the meaning of excitation? Here electron present at the ground state, that is n equal to 1. These energy levels, okay, the circular path or orbits for the energy level, here n equal to 3. But for the hydrogen, which is the ground state, n equal to 1 is the ground state, because only one electron is present. So 1s1 anta bariತೀವಿ. 1s1 indicates what? First shell, or you can say it's an K shell. K shell anta kuda karitare. Here energy is present, but sometimes it may absorb energy or emit energy. When it absorb energy or it emit energy, this electron at the ground state, if you heating or irradiate, then this electron will jumps to next energy level there which is unstable, here it should be absorb energy, then unstable state 2 backs to its ground state. Here it will emit energy in the form of heat or light, okay. So that's why their energy will change, but it will retain its energy. Illi ee electron ಗೆ ಯಾವ energy ಇದೆ that should be retained, it does not change with the time. But ಇಲ್ಲಿ ಯಾವುದು ಎಷ್ಟು ಅಬ್ಸರ್ವ್ ಮಾಡ್ಕೊಂಡಿದೆ ಎನರ್ಜಿ ಅಷ್ಟೇ ಎನರ್ಜಿನ ಎಮಿಟ್ ಮಾಡ್ತದೆ. ಎನರ್ಜಿ ಆಫ್ an electron should be retained. That should be the second point. Energy of electron does not change with the time. Understood? Okay, next we'll move for the frequency. Go for the frequency wise. First we'll read out the postulates. What is the frequency of an radiation absorb or emit when transition occur to stationary state? Here which is the stationary states? Here n equal to 1 is the one of the stationary state, n equal to 2 is the one of the stationary state, and n equal to 3 is the next stationary state. So hige it may up to infinity. Okay, so hage one add ಮಾಡ್ತಾ ಹೋಗುವಂತದ್ದು shells, it may up to n equal to infinity. So here what is that? Frequency of radiation absorb or emitted. ಇಲ್ಲಿ absorb ಕೂಡ ಮಾಡ್ಕೋಬಹುದು, emit ಕೂಡ ಮಾಡಬಹುದು. absorb ಮಾಡುವಾಗ ಏನಾಗ್ತದೆ, ground state ಇಂದ excited state ಗೆ jump ಆಗ್ತದೆ. When electron will jump to ground state to excited state. Ground state means what? While writing the electronic configuration, ಎಲ್ಲಿ electron exact ಆಗಿ end ಆಗ್ತದೆ, that orbit is a ground state. Excited state means what? Next empty stationary states. Here for hydrogen, electron ended with the first orbit only, so it is an ground state. Next excited state, stationary state yavadu? N equal to 2, n equal to 3 also there, n equal to 4, 5 like till infinities. Okay, so this point, frequency of radiation absorb or emit when the transition occur between the two stationary states. These two stationary states can produce the frequency or absorb the frequency that can indicate by mu. Mu is nothing but, okay, so here mu equal to, you know the formula, E is equal to h nu, Here from this we should take the transition occur between two energy states. That's why we can take in delta E. Then if you want mu equal to delta E by h. ಅದನ್ನೇ ಇಲ್ಲಿ ಕೊಟ್ಟಿರುವಂತದ್ದು delta E by h. What is the meaning of delta E? Delta E is change in energy. That change in energy should be higher energy level to lower energy level, okay, or absorb ಆದರೆ ground state in the excited state. E2 minus E1 by h. Delta E is nothing but change in energy, that is equal to E2 minus E1. If it is E1, the first stationary state, here E2. Here difference between these two is frequency of radiation. Then this is the third point and very important. Okay, I already told for 3 marks, it's 90% sure question. Then we move for the important one, the fourth, that is angular momentum of electron. Is quantized. Here what is the meaning of angular momentum? So already told in the first postulates, electron revolve around the nucleus in a circular path. That means what? It moves around in a nucleus, okay, and this electron can exhibit the particular angular momentum that should be quantized. Here e orbital electron ಗೆ there should be fixed value of angular momentum, and that angular momentum can be expressed by mvr equal to nh by 2 pi. Here what is the meaning of me? Me is the mass of an electron. Me is mass of electron. Then v is the velocity of electron, and r is the radius means what? This distance, okay, r is the radius. Okay, in other words, angular momentum is equal to the integral multiples of h by 2 pi. That means what? Here n equal to 1 adre mvr equal to h by 2 pi. If n equal to 2 means what? Second energy level, that's equal to n should be substitute by 2. Then we can take h by pi value only, h by pi value for the angular moment for second orbital. Here one more term, what is that? Radiation emitted or absorbed only the transition of electron. ಇಲ್ಲಿ transition of electron ಆದರೆ ಮಾತ್ರ ಈ ಪಾಯಿಂಟ್ ಆಲ್ರೆಡಿ ಹೇಳಿದೀವಿ ಇಲ್ಲಿ ಸೆಕೆಂಡ್ ಥರ್ಡ್ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ. ಓಕೆ, so what is that? Angular emit radiation or absorb radiation by the transition only, by the transition only. These four are the very important postulates for the exam point as well as your theory part also. Okay, ಇದರ ಬೇಸಿಸ್ ಮೇಲೆ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಒಂದು ಕ್ವಶನ್ 100% ಇದ್ದೇ ಇರ್ತದೆ. ಓಕೆ, so these are very important. Then we'll move for the sub points regarding this concept. Okay, sub point regarding this concept. The first point in a Bohr's atomic model, stationary states of electron is represented by the n. Stationary states of electron will represent by the n. In case ಇದು ಹೈಡ್ರೋಜನ್ಗೆ ಮಾತ್ರ, ಹೈಡ್ರೋಜನ್ಗೆ ಗ್ರೌಂಡ್ ಸ್ಟೇಟ್, ಇದು ಸ್ಟೇಷನರಿ ಸ್ಟೇಟ್, ಇಟ್ಸ್ ಆಲ್ಸೋ ಸ್ಟೇಷನರಿ ಸ್ಟೇಟ್ ಅಂಡ್ ಇಟ್ಸ್ ಆಲ್ಸೋ ಎ ಸ್ಟೇಷನರಿ ಸ್ಟೇಟ್ಸ್. ಅಗೇನ್ ಇದರಲ್ಲಿ ಎರಡು ಟೈಪ್ಸ್ ಬರೋದು ಯಾವುದು? ಗ್ರೌಂಡ್ ಸ್ಟೇಟ್ ಮತ್ತೆ ಎಕ್ಸೈಟೆಡ್ ಸ್ಟೇಟ್. ಫಾರ್ ಹೈಡ್ರೋಜನ್ ಗ್ರೌಂಡ್ ಸ್ಟೇಟ್ n equal to 1. Rest all energy levels are what? Excited state, excited state. So that will indicate by n. N is equal to integer 1 2 3 4 till infinity, and which is called as a principal quantum number. Principal quantum number that we'll discuss later. Okay, ಮುಂದೆ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಬರ್ತದೆ, ಆಗ ಡಿಸ್ಕಸ್ ಮಾಡ್ತೀವಿ. And you should remember stationary states are called as an principal quantum number. So that value starts from the 1 to infinity. Okay, next, radii of a stationary state, particularly radii of this what? R1. Now I will take nucleus to first n equal to 1, R1 here to here, R2 here to here, R3. These are the radius of particular stationary states of an electron, where the electron is present, ಅದಕ್ಕೆ ಹೇಳುವಂತದ್ದು. And that should be formulated by Rn equal to n square by a naught, here picometer, a naught picometer. Rn is the any stationary states, and n square equal to what particular state? N equal to 1 2 3 4 like that. So a naught value, it's a constant, and a naught equal to 52.9 picometer. 52.9 picometer. Here, this is a formula for calculating, find out the radius of particular atom. And one more concept, if n equal to 1 is nothing but the hydrogen ground state energy level. Okay, so here n equal to 1 ಆದರೆ Rn equal to Rn or R1 equal to 52.9 picometer, and this is called as an what? Bohr's orbit. This is called as an Bohr orbit. ಹಾಗಾದ್ರೆ according to that condition, this is an Bohr orbit. ಯಾಕೆ? n equal to 1, and radius of the first stationary state is called Bohr. Okay, definition exact ಆಗಿ ಬೇಕಿದ್ರೆ we can write radius of a first stationary state is called as an Bohr orbit, or you can substitute the value of first stationary state n equal to 1, R1 equal to 1 square a naught value is constant 52.9 picometer. ಹಾಗಾದ್ರೆ we can say radius of hydrogen atom is equal to 52.9 picometer. This is the second sub point in a particular Bohr's atomic model. Now we'll move for the energy. Already we discussed what Rn, radius is over. Go for the energy of a stationary state. These stationary states are having the particular energy that is equal to En is an energy of a stationary state, any stationary state, that's equal to Rh into 1 by n square into joule, in terms of joule. So here Rh is Rydberg constant. Okay, Rh is Rydberg constant, but it's in terms of what? Energy ಗೆ Rh value that's equal to 2.18 into 10 power minus 18 joule. Rh value is constant. Okay, that constant value that's equal to 2.18 into 10 power minus 18. Okay, so which is reverse for the nu bar that we'll discuss later. Okay, nu bar ಬಂದ್ರೆ wave number ಗೆ Rh value 109 677 ಬರ್ತದೆ. ಅದನ್ನು ನಾವು ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡಲಿಕ್ಕೆ ಇದೆ. ಓಕೆ, ಸೊ mu bar ಬೇರೆ EH ಬೇರೆ, ಡೋಂಟ್ ಕನ್ಫ್ಯೂಸ್ ವಿತ್ ದಿಸ್. ಹಿಯರ್ En ಗೆ RH ವ್ಯಾಲ್ಯೂಸ್ ಶುಡ್ ಬಿ 2.18 into 10 power minus 18 joule for the wave number 109677. Okay, meter. Now we'll calculate the first energy level, that is this energy level. ಇದ್ರದ್ದು ಎನರ್ಜಿ ಲೆವೆಲ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಾದ್ರೆ n equal to 1, substitute n equal to 1 RH into 1 by 1 square, 1 by 1 square, that's equal to minus 2.18 into 10 power minus 18 joule. This is our first energy level in a energy. Okay, so E2, calculate for the E2 RH value in case this electron will excite it to next energy level. In case this electron will excite to next energy level, then we should calculate the second energy level energies. Okay, so what is the value? See, RH 2.18 into 10 power minus 18, 1 by 2 square, that's nothing but 4. We can write 0.545 into 10 power minus 18 joule per joule is the energy of the second orbit. ಹಾಗೆ ನೀವು ಬೇಕಿದ್ರೆ ಮುಂದೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತಾ ಹೋಗಬಹುದು. And these all points are okay. And one more concept in energy, electron free from the nucleus. That means what? In this stationary state it can reach up to infinity. Okay, so electron infinity stage ಅಲ್ಲಿ ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ, or in another word hydrogen should be ionized. Ionized ಅಂತ ಹೇಳಿದ್ರೆ ಕಂಪ್ಲೀಟ್ ಆಗಿ ಎಲೆಕ್ಟ್ರಾನ್ ನ ತೆಗೆಯುವಂಥದ್ದು. electron free from the nucleus, then the energy is taken as 0, or you can directly substitute for the formula En equal to infinity. Hello, infinity alide. So 1 by infinity is nothing but 0. 0 into 0, then E equal to E infinity equal to 0. E infinity equal to 0. Then that particular hydrogen is called as an ionized hydrogen atom. Ionized hydrogen atom. Okay, so electron free from the nucleus anta helide, which is far from the nucleus. Okay, where it is present, ultimate stage alli irudu, last energy level, that should be infinity, so that should be taken as 0. Okay, these all point regarding the hydrogen only, which is applicable only for the hydrogen, and he may apply, okay, he can also applicable hydrogen like atoms. Which are the hydrogen like atoms? Hydrogen like atoms ಆಗಬೇಕಾದ್ರೆ hydrogen na properties na show ಮಾಡಬೇಕು. Here it is in terms of what? Electron. We can take in the basis of electron only. Electron should be ಎಷ್ಟಿದೆ ಇದರಲ್ಲಿ? ಹೈಡ್ರೋಜನ್ ಅಲ್ಲಿ 1 ಇದೆ. ಹಾಗಾದ್ರೆ ಬೇರೆ ಯಾವ ಎಲಿಮೆಂಟ್ ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ 1 ಇರ್ತದೆ? ಬೇರೆ ನ್ಯೂಟ್ರಲ್ ಆಟಮ್ ಅಲ್ಲಿ ಆಗ್ಲಿಕ್ಕೆ ಚಾನ್ಸೇ ಇಲ್ಲ ಎಲೆಕ್ಟ್ರಾನ್, ಬಿಕಾಸ್ ಎಷ್ಟು ಪ್ರೋಟಾನ್ ಇದೆ ಅಷ್ಟೇ ಎಲೆಕ್ಟ್ರಾನ್ ಇರುವಂಥದ್ದು. ಹಾಗಾದ್ರೆ ಅಯೋನೈಸ್ಡ್ ಕಂಡೀಷನ್ ಆಟಮ್ ಕ್ಯಾನ್ ಅಪ್ಲಿಕೇಬಲ್ ಫಾರ್ ದೀಸ್ ಫಾರ್ಮುಲಾಸ್. ವಿಚ್ ಆರ್ ದೇ? ಸೊ ಫಸ್ಟ್ we'll take He plus. It is an hydrogen like atom. Why? Because atomic number 2 here 4. 2 is proton, 2 minus 1, yake plus 1 is there, 2 minus 1, that's equal to 1 electron. Here 1 electron. One more, lithium, Li2 plus, Li2 plus. Here also 3 minus 2, that's equal to 1 electron. These all are comes under hydrogen like atoms. Hydrogen like atoms. So for the hydrogen like atoms, we can take the formula or modify the formula by substituting the Z square value. What is that? En equal to RH Z square by n square. Here Z is nothing but atomic number. Z is atomic number. Atomic number anta helidre enu? Where the subscripts are present in an atom or element ಅಲ್ಲಿ subscript ಏನಿದೆ ಅದನ್ನ ನಾವು atomic number ಅಂತ ಕರಿತೀವಿ. Okay, substitute all those values. For example, lithium Li2 plus. Li2 plus ಗೆ ಮಾತ್ರ, not for lithium Li2 plus, because lithium ಅಲ್ಲಿ 3 electron ಇರ್ತದೆ. Li2 plus ಅಲ್ಲಿ only 1 electron is there. Z value is 3 square 9 by n value is ಕರೆಸ್ಪಾಂಡಿಂಗ್ಸ್ ಆಗಿ ಯಾವ್ದಿರ್ತದೆ ಅಂತ ನೋಡ್ಬೇಕು. n ವ್ಯಾಲ್ಯೂ ಶುಡ್ ಬಿ 1 ಬರ್ತದೆ, ಅದನ್ನು ಕೂಡ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡ್ತೀವಿ. ಆರ್ ಐ ವಿಲ್ ಟೆಲ್ ಹಿಯರ್ ಓನ್ಲಿ ಫಾರ್ ದಿ ರೈಟಿಂಗ್ ದಿ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ Li plus 2. Here how many electrons are there? Only 1 electron is there. 1s 1 is possible. 1 is possible. Here that numbers, whatever the numbers are present, that is the principal quantum number. That is the principal quantum number. So here substitute n equal to 1. Okay, helium kuda hage bartade. Okay, now you just taken formula. Rest all problems we will discuss later. So formula ಏನು En equal to minus RH z square by n square. And what about the radius? Radius also changes, right? Because ಇಲ್ಲಿ radius ಯಾಕೆ change ಆಗ್ತದೆ? ಹೈಡ್ರೋಜನ್ ಮತ್ತೆ ಹೈಡ್ರೋಜನ್ ಲೈಕ್ ಅಟಮ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ ಸೇಮ್ ಇರೋದು. ಇಲ್ಲಿ ನೋಡಿ ಹೈಡ್ರೋಜನ್ಗೆ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಇರೋದು, Li2+ ಕೂಡ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಇದೆ. ಬಟ್ ದರ್ ಇಸ್ ಎನ್ ಚೇಂಜ್ ಇನ್ ಅ ರೇಡಿಯಸ್. ವೈ? ಬಿಕಾಸ್ ಹೈಡ್ರೋಜನ್ ಒಂದು ಪ್ರೋಟಾನ್ ಇರ್ತದೆ, ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್, ದಟ್ಸ್ ಓಕೆ. ಬಟ್ ಇನ್ ಅ ಲಿಥಿಯಂ ಹೌ ಮೆನಿ ಪ್ರೋಟಾನ್ಸ್ ಆರ್ ದೇ? 3 protons are there. In case 3 protons are there, orbital is same, then what happens? Orbital will undergo shrinking, because effective nuclear charge is more in a lithium plus than the hydrogen. So this will comes like this. Illi barbodu atomic radius will be reduces for the hydrogen like atom. That's why here modify the equation. What is that? R equal to A naught n square by Z. A naught n square by Z. This is the formula. Here also again Z is an atomic number. I hope you understood this concept, and which is very important. In the next class we will discuss the some drawbacks present in a Bohr's atomic model, as well as line spectrum of the hydrogen atom. Okay, thank you.